Hi everyone, my name is Engineer Arjun Singh and today I'm going to tell you about photoelasticity. What is photoelasticity? Is the property of a transparent isotropic material when subjected to either tension or compression. It basically leads to birefringence, or you can say doubly refracting, which basically means a ray of light when incident on an object, it divides into two parts. That's why it's termed as birefringence. Now on the resultant, basically we know the value of stress and the direction of principal stresses. Now what leads to, or what causes birefringence? When an isotropic material is subjected to different kinds of loads like tension or compression, which leads to a development of stresses in that object, that results in the loss of physical isotropy of that object, which leads to the birefringence of that, or you can say leads to the doubly refracting property of that particular transparent object. Now the stress patterns are basically observed in the sense of fringes. Fringes are nothing but the you can say interference of lights, interference of rays on that object. Now when a ray of light is incident on that object, it basically is an unpolarized light. So we need to polarize that light. Polarization basically means converting that light into a single phase system so that we can read it properly. So the polarized light, when it is subjected to the transparent stressed object, we get to know the different kinds of fringe patterns. We see different kinds of fringe patterns. Now in that case, basically we get two different kinds of lines which are obtained. When we use monochromatic light, we get isochromatic lines. Isochromatic lines are lines which depict the magnitude of stresses, and when we use white source light, basically we get the isoclinic lines, which basically represents the direction of principal stresses. So it is the loci of principal stresses direction, so which means in that particular line, the value of the direction of principal stresses is same at all the points. And in case of the isochromatic lines, basically it is nothing but the first principal stress, the difference between the first principal stress and the second principal stress is constant in that particular loci of isochromatic points. So this is what is basically read and what is analyzed in this particular photoelasticity method. Photoelasticity method is a non-destructive kind of a method. So there are different kinds of methods which can be used to calculate stresses in an object. You can use computational method also, but computational method is used when the object is not being constructed and we are analyzing and designing the object. At that phase we use computational methods like FEM softwares, ANSYS and all, to know the stress what could occur at that particular point, or that what would be there. But in case of photoelasticity, it has a huge application in aeronautical industries, where the parts of an aircraft are to be analyzed, where is the stress maximum after being constructed, so that or you can make a prototype also of an photoelastic object, so that you can get to know the you can get to know the where is the maximum stress values. So this is how photoelasticity is being used, and it has a huge application in civil engineering also, to know where could be the maximum stress in a beam, or where is the where are the directions of principal stresses and so on. So this is all for today. Thank you everyone for watching.